in section 2, we're going to take a look at similar polygons. So when we talk about what similar polygons are, it's two polygons. So we have that two polygons are similar if and only if their corresponding angles are congruent and the measures of their corresponding sides are proportional. So what that basically means is similar polygons are the same shape, but they are different sizes. So let's take a look at how we write a similarity and how we determine if two shapes are similar. So the symbol we use for similarity is basically that part of the congruent symbol just without the equal. So that little squiggle on top of the congruent symbol, that's the only part we use to write two shapes are similar. So if we're going to do an example, I'm going to the best of my ability, draw two rectangles, okay? So we're going to label the rectangle on the left A, B, C, D, and we'll label the rectangle on the right E, F, G, H. So in a rectangle, we know all angles measure 90 degrees. And then we're going to have, let's say, side AB and CD have lengths 8 and BC and AD have length 6. And then in our second rectangle, we have EF and HG having lengths 4 and FG and EH having lengths 3. Okay. So I already know these figures are similar. All of their angles are congruent and their sides are all proportional. So the way I'm going to write the similarity statement is I'm going to say A, B, C, D, and I'm going to draw my similarity symbol, similar, and then I want to make sure I list corresponding sides in order. So we're going to go E, F, G, H. So just like when we write a congruent statement, the order matters in a similarity statement as well. So I have to make sure corresponding angles that are congruent line up, as well as the corresponding sides that are proportional also are in the same order. So when we talk about which angles are congruent, we know that angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. And then when it goes to write the corresponding sides, we write a proportion. So we don't say like AB equals EF. What we do is we set up the ratios of all of the corresponding sides. So AB over EF equals BC over FG, which equals CD over GH, which equals AD over EH. So what this means is if I plug in all of the lengths of these sides in, I will get the exact same ratio for each corresponding pair of sides. So let's do an example. We want to determine whether the pair of figures is similar, and we want to be able to justify our answer. So the easiest place to start when we're determining a pair of figures is similar is to go with congruent angles. So we know the measure of angle B and the measure of angle A in our first triangle. So we need to find the measure of angle C. Well, we know that the measure of the angles in the triangle is 180 degrees. So if I just subtract 80 and 60, we'll get the measure of angle C being 40 degrees. Okay. So now in our second triangle, we have angles S and T, we're just missing angle R. So same thing, the measure of the angles has to be 180 degrees. If I subtract 80 and 40, we get the measure of angle R is 60. So if we look at corresponding angles, we have that angle A is congruent to angle R. We have angle B is congruent to angle S, and we have angle C is congruent to angle T. So we do have corresponding angles congruent. Right? Now I can use the corresponding angles that are congruent to set up my corresponding sides to figure out if their ratios are proportional. So we know that AB over RS has to equal BC over ST, which has to equal AC over RT. And it is important to point out that at this point, all three ratios have to be equivalent. If just one of them isn't the same, then the figures are not similar. So now we're going to plug in our known side lengths. So we are going to end up with 5.2 over 3.9 equals 7 over 5.25 equals 8 over 6. Okay. Now, just looking at those ratios, I don't know that those are all the same. All right, so what we can do is we can go, especially since there's decimals, we can go ahead and divide those numbers. So I do 5.2 divided by 3.9. You're going to get 1.3 repeating. So we have 1.33 repeating. When we do 7 divided by 5.25, we also get 1.33 repeating. And when we do 8 divided by 6, we get 1.33 repeating. So all of the ratios of corresponding sides are the same, which means my sides are proportional. So I have corresponding angles congruent, I have my corresponding sides proportional. So yes, these figures are similar, and then the justification would be this work we have showing corresponding angles being congruent and our corresponding sides being proportional. So now let's take a look at something called scale factor. So the scale factor is that numerical ratio we get when we compare the lengths of the corresponding sides of our similar figures. So in that previous example, the 1.33 is our scale factor. Now typically we do leave scale factor as a fraction, or we can write it as a ratio. So we wouldn't leave it as 1.33 typically, because that is a decimal. We would write it as a ratio. So let's take a look at our example. That says some special effects in movies are created using miniature models. In a recent movie, a model SUV 22 inches long was created to look like a real 14 2/3 foot SUV. What is the scale factor of the model compared to the real SUV? So it's important to know how your scale factor is set up. So when we try to figure out our scale factor and we set up our ratio, we have to figure out what goes on the top and what goes on the bottom. And it tells us in the problem, we're doing the scale factor of the model compared to the real SUV. So our model is pretty much A, and the SUV is B. So we want to put model over SUV. So now we start looking at our values. So we have the model being 22 inches long, and we have the real one as 14 2/3 foot. It's also important to pick out here that our units are not the same here. We're comparing inches and feet. So we gotta make sure our units are the same. So it's easier to convert 14 2/3 feet to inches, so that's what we're gonna do. So 14 2/3 feet, if you use the fact that there are 12 inches in a foot to do the conversions, we end up with that's the same as 176 inches. So now I can plug in values for my scale factor. So my model is 22 inches compared to the real SUV, which is 176 inches. So we have 22 over 176. But if you remember from section 1, I said it's always a good idea that we want to simplify that scale factor. So if I simplify 22 over 176, it becomes 1/8. So our scale factor is 1/8. Another way you can write it, because it is a ratio, it's a ratio of 1 to 8. So what that means is 1 inch in the model corresponds to 8 inches on that real SUV. So that's what our ratio is telling us here. Our scale factor, I should say. Looking at our last example, we know our two polygons are similar. So first we want to write our similarity statement, then we want to find x, y, and uv, and lastly we want to find the scale factor of polygon ABCDE to polygon RSTUV. So let's start with that similarity statement. So I'm going to start with the polygon on the left, and I'm going to name it. And I'm just going to start, because it's the alphabet, I'm going to start at the beginning. So we have A, B, C, D, E, and we have our similarity symbol. And when you're trying to figure out how to name your second polygon, go off the congruent angles. So we know which angles are congruent. A and R are congruent. So we're going to start with R. Then we know B and S. Then C and T. D and U. And lastly, E and V. So writing a similarity statement, always best to go off the congruent angles. It's the easiest way to write your similarity statement. And it's all based on which letter you start with. If I had started with B, it would have changed how I labeled my second polygon. Now let's go on to the second part, where we want to find X, Y, and UV. So let's start with finding X. So if we look, X is the length of side CD. So we want to find that length. Well, the corresponding side to CD, if we look at our similarity statement, is TU. So we want to be able to set up a proportion to help us solve for X. So we know we're going to have X over 3. And when you're trying to figure out what your other ratio should be, always good to use a pair of corresponding sides that you already know the lengths of. Like, we already know AB and RS. So when we set up our proportion to solve, we're going to put AB over RS, so 6 over 4, equals CD over TU, so we get X over 3. So we have our corresponding side set up. So then we're going to use cross multiplication to solve. So we'll do 6 times 3 equals 4 times X. So we get 18 equals 4X. Divide both sides by 4. And I put over here, we get that X equals 4.5. Next, we want to solve for Y. So we're going to use the same known sides of AB and RS, but now we have to use sides DE and UV, since Y is contained in side UV. So when we set up that proportion, we're going to still have 6 over 4, but this time we'll have it equal to 8 over Y plus U, Y plus 1. So we still cross multiply. We get 6 times Y plus 1 equals 4 times 8. Distribute the 6, and we end up with 6Y plus 6 equals 32. We then subtract 6 from both sides, and we get 6Y equals 26. And then we're going to divide both sides by 6. Now when we do that, we get the decimal 4.3 repeating. And it's going to be helpful for us to leave it as the exact value. So when I convert that back to a fraction, we get that Y equals 13 over 3. And the reason I did that is because we want to make sure that we are giving exact answers, because we want to make sure that our ratio, if we were to set it up for our side lengths, is all the same going across. The last part in B asks us to find the length of UV, which is only possible once you know Y, because UV is equal to y plus 1. Well, we know y is 13/3, so I want to do 13/3 plus 1. So anytime you're adding two fractions, they have to have common denominators. So this is technically 1 over 1, which I can rewrite as 3 over 3. So when we add 13/3 and 3/3, we get that uv equals 16 over 3. So we go back up here to b, and we can write that uv equals 16 over 3. And the last part of our problem asks us to find the scale factor. So the scale factor of A, B, C, D, E to R, S, T, U, V means we want to put a side from the polygon on the left over a side from the right. And I'm going to choose the whole number side, so I don't have to deal with dividing two fractions or a number in a decimal. So when I do that, I'm just going to use the AB over RS, so we get 6 over 4, which can be simplified. I can divide both of those by 2 and we get 3 over 2. So my scale factor is 3 over 2, or if I want to write it as a ratio, 3 to 2. So let me know if you have any questions over the notes on determining if two polygons are similar.